Okay, today we're going to look at concavity and the first derivative and a graph of the first derivative. And we're going to look at answering questions by just looking at the graph of the first derivative. Well, the first question is, you're given f prime of x in the picture. You're given when x is 0, y is f prime of 0 is 12. You're given that f prime of 1 is 0 and f prime of 2 is 0. So what you're kind of given there is they must be turning points because it's where the derivative is equal to 0. But let's get the equation of f prime of x. Well, this is a parabola and you're given x-intercepts. So it's pretty straightforward. The first thing you write down, because it's 1, x minus 1 and x minus 2, you just multiply it by that. You don't know what a is. So if you've got factors, you just go the x minus those things, the opposite of those factors in brackets. That's going to be the equation. Now they gave you that 0 and 12 as a point, so you put 0 in for x and 12 in for y, and you get minus 1 times minus 2, divide by 2, you get a is equal to 6. Now we've got the equation of the derivative. Multiply it out, it's 6x squared minus 18x plus 12. Okay, now the next question is determine f of x. And we can see what Mr. Autry does. We've got that f prime of x is equal to 3ax squared plus 2bx plus c. You just take the derivative of that function. But hey, we know that 3a is equal to 6. So a must be 2, because we're looking at the derivative. We know that b must be equal to minus 18. So that's b is equal to minus 9. We already know that c is 12 in here. So c is 12 because it's the y-intercept. So there is the equation. F of x equals 2x cubed minus 9x squared plus 12x. The next question asked back here, by referring to the diagram, can you say which part of the graph of x, f of x, has stationary points? Which values of x make the stationary points? Well, it's where the gradient is 0. So the values must be 1 and 2. That's pretty straightforward. The next question says, by referring to the diagram, determine the values of x for which f of x is increasing or decreasing. Well, you're kind of looking at it right here. It's increasing when x is less than 1 or greater than 2. It's increasing where f prime of x is positive. And it's decreasing in between 1 and 2. But it's increasing when x is less than 1 or x is greater than 2. And then the last question, they say, identify the local minimum or the local maximum. Well, you know it's a turning point, so it's either a minimum or a maximum. But you can take, if you take the gradient of this derivative, that's the telling you about its concavity. Well, that's negative, and so that must be concave down. So it must be a local maximum because it's at the top of a concave down thing. And on the other side, you see it's positive, it must be concave up. So that must be a local minimum. That's the concavity there. You get that from the second derivative. You don't have to do the second derivative. You could just look at the gradient of the graph of the derivative. And I think that's maybe enough ideas for one little video. Okay, and I'm trying to look for the turn off. Okay.